Hey there. Ever stop to think about what a gust of wind, a flowing river, and a speeding car all have in common? They're all moving, sure, but they all share something much more powerful, a hidden energy. We're going to dive into what that is, it's called kinetic energy, and see how it pretty much shapes everything around us.
All right, let's start with a really simple but kind of profound idea. Things that move can make other things happen. In the world of physics, we call that doing work. But what's the common link here? What connects the motion of an object to its power to actually change its surroundings? So let's chew on this for a second. On one hand, you've got a tiny little bullet. On the other, a massive, powerful river. They couldn't seem more different, right? But believe it or not, they share this powerful, invisible quality. Any guesses what that is?
Well, it all comes down to their ability to do work just because they're moving. And the faster something moves, the more work it can do. It's the whole reason moving water can spin a giant heavy turbine to make electricity, or why a strong gust of wind can get a windmill going. Their motion is their energy. Okay, so we've seen this principle in the wild. Now, let's do what scientists do and give it a proper name and figure out exactly what it means.
And there you have it, kinetic energy. That's the official name for this power of motion we've been talking about. And seriously, every single thing that has speed, from a marble rolling across the floor to planets zipping around the sun, it all has kinetic energy. Now here's a really cool way to think about how we measure it. The amount of kinetic energy an object has is exactly the same as the amount of work it took to get it moving in the first place. You can think of it like this. The energy you put in to get it up to speed is the energy of motion that it now has stored up.
So how do we actually put a number on this? Well, physicists have this incredible formula to calculate it. And don't worry, we're not about to get lost in the weeds with a bunch of heavy math. I just want to show you how elegantly it's all put together from just a few basic ideas.
You can see how it starts with the real fundamentals, right? Work, force, motion. Then, physicists just combine these core equations, swapping in variables from one to the other, and after some really clever simplifying, where things like acceleration just cancel each other out, and assuming we're starting from a dead stop, we are left with this one beautiful final equation that tells us everything we need.
And this is it. This is the key to everything. Kinetic energy equals 1/2 of an object's mass times its velocity squared. This simple little equation is incredibly powerful. It unlocks the secrets of the energy of motion. Okay, so now that we have the formula, we can ask a really fun question. You've got two parts here, mass and velocity. Which one do you think has the biggest impact on an object's kinetic energy? Let's find out. Let's just run a quick thought experiment. Picture a car driving down the highway. What happens to its energy if we could magically double its mass? And then what happens if, instead, we just double its speed? Well, if you double the mass, it's actually pretty straightforward. You look at the formula, and yeah, you get twice the kinetic energy. It's a direct relationship. One goes up, the other goes up by the same amount. Simple enough, right? But this is where it gets crazy. If you double the velocity, the kinetic energy doesn't just double, it becomes 4 times greater. Why? Because that velocity term in the formula is squared. So even a small change in speed has this huge outsized effect on the energy. And that right there is probably the most important thing to remember from all of this. An object's energy is so much more sensitive to changes in its speed than to changes in its mass. That little squared symbol over the velocity is the absolute key. Okay, so I promise this isn't just theory for a physics class. This principle plays out all the time in the real world in situations you've definitely experienced.
Have you ever done this, or at least noticed someone else doing it? You're driving along, you see a massive hill up ahead, and your gut instinct is to hit the gas before you even get to it. What's the physics behind that?
What you're actually doing is banking energy. By speeding up, you are dramatically increasing your car's kinetic energy. You're basically loading it up with the energy of motion so that it can then spend that energy to do the hard work of fighting gravity and climbing up that hill.
And that brings us to our final and maybe most important thought for the day. We now know that doubling a car's speed quadruples its kinetic energy. So, what do you think that does to the distance it takes to bring that car to a complete stop? The answer to that question has some pretty serious implications for every single one of us on the road.